I'm going to discuss part 1 of two-dimensional geometric transformations. This is our lesson number 4. First, let's see types of transformations. In this lesson, we are going to discuss three types of transformations. One thing is translation. The second one is scaling. Okay, scaling, and third one is rotation. Now first let's see translation. So we have to consider a point P. So for that let's consider the coordinate system. This is our x-axis and y-axis. This is the origin. Okay, now we have a point P. It moves here and to this position. Okay, so now coordinates of point P that is x and y. Okay, coordinates of point P x comma y, and coordinates of P1 x1 and y1. P1 x1 comma y1. Okay, then here now let's see this amount is Tx and this amount is Ty. That means in the positive direction of x-axis we have Tx amount, and in the positive direction of y-axis we have Ty amount. Therefore, now x1 means x plus Tx, y1 means y plus Ty. So now in order to represent this we use matrices x1 y1 1. This one, so we have here we have x y1. That means this is our point P1. Okay, this is our point P1 and this is our point P. Here, in order to get this, we have to put this is a 3 by 3 matrix. Okay, that means we have 3 rows and 3 columns. In order to get this part, we have to write 0 Tx. Then I hope you are familiar with matrix multiplication. 1 into x, x, okay, 0 into y, 0, Tx into 1, Tx. then you will get x plus tx. Next line, y equals y plus ty. That means here we have to put 0, 1, ty. Uh, 0 into x, 0, 1 into y, y, ty into 1, ty. Okay, so you can get this part, and now here we have 1. In order to get this, you put 0, 0, 1. 0 into x, 0, 0 into y, 0, 1 into 1, you get 1. Okay, now you can see here we have represented coordinates of point P1, okay, P1, and here we have represented coordinates of P, and this matrix we call it T, Tx, comma Ty, and that is what we have shown here. Okay, now let's move to scaling. We have a point P. Point P, coordinates of it is this one, P1, x1, y1. Then we have a relationship where x1 equals simple as x into x and y1 equals sy into y. Now as in earlier situation, we need 3 by 3 matrix. So here we have x1, y1, 1, and now here we have x, y, 1. Now in order to get this x into x, here we have sx 0, 0. Then you will get xx into x, this term, then 0, 0. And in order to get this, here you have 0, sy, 0. Now in order to get this one, you have to put 0, 0, 1. 0 into x, 0, 0 into y, 0, 1 into 1, 1. Okay, so now here you know this is the coordinates of point P1, this is the coordinates of point P, and this is this matrix. We represent it as Sx comma Sy. Okay. Now let's move to the third one, that is rotation. So in order to understand that, let's use the coordinate system, and this is the origin. Okay, so it says the point P rotates around the origin by angle theta in anticlockwise direction, this direction. Okay, then let P is x comma y and P1 is x1 comma y1. Now you have a point, okay, that is P. Coordinates of P is x comma y. Now P rotates around the origin by an angle of theta, and it comes to here, to P1, and now this is our theta, and you can see it occurs in anti-clockwise direction. Okay. Now here let's therefore here let's say A, okay, then this one let's say A1, and here this one let's say B1, and B. Now coordinates of P1 is x1, y1. Now we want to develop a relationship between these two coordinates, and in order to do that, let's take this angle as alpha. Then we know OP equals OP1, because here it rotates around the origin. Okay, so let's consider value of OP as R, then OP1 also, the value of OP1 will also be R. Then let's consider the angle, the triangle OAP. If you consider this triangle OAP, then you can, this is X, okay. X value here R cos alpha. Then this value Y, that is R sin alpha. Now if you consider OA1P1 triangle, OA1P1, if you consider this triangle, here you can see X1 means R cos alpha plus theta, R cos alpha plus theta. Okay, then y1 means R sin alpha plus theta. Okay, then we can expand x1 value Okay, let's expand x1 value, this one r, here cos alpha cos theta minus sin alpha sin theta. Okay, then again here let's try to form this value and this value here. R cos alpha cos theta minus r sin alpha sin theta. Now here we have for the r cos alpha we can substitute x cos theta minus for r sin alpha we can substitute y sin theta. Okay, that is our x1 value. Then for y1 r, this one we can expand sin alpha cos theta plus cos alpha sin theta. Now again we try to form these two values. Here r sin alpha cos theta plus r cos alpha sin theta. Okay, now here to the r sin alpha we substitute y cos theta plus r cos alpha we put x sin theta. Now these are the two values. Okay, for x1 we get this value, for y1 we get this value. Now we should try to write it in a matrix. Okay, now here to x1 we have to form x cos theta minus y sin theta, x cos theta. So since space is not enough, I will write it like this. Okay, here we have xy1, then x cos theta minus y sin theta, x cos theta. Okay, this we try to form a 3 by 3 matrix here. X cos theta minus y sin theta, that's on all. So here we put 0. Now you will get x cos theta minus y sin theta plus 0. That means this one. So we have to form this one. Here x sin theta y cos theta here 0, x sin theta y cos theta plus 0, you will get this one. And now here you put 0 0 1 in order to get this value, 0 into x0, 0 into y0, 1 into 1 1, you get this one. And here this is our coordinates of point P1. Okay, so this is P, point P, and this one is our r theta. Okay, in that way, now we have derived matrices, 3 by 3 matrices for translation, scaling and rotation. That is the end of this lesson, and thank you for listening.